Welcome to the Gray Learning webinar. I have been associated with Great Learning for close to 1.5 years now. I have been teaching data science, data engineering programs. A bit about myself: I lead technology for a predictive analytics team at Milliman, which is one of the world's biggest boutique actuarial consulting company. Done my bachelor's in computer science, did my master's in machine learning from Georgia Tech. I have, it's a typo here, these are not infamous companies. These worked with famous companies like Mu Sigma and Amazon. And then I lead a cross geography team of data scientists, data engineers, DevOps folks, information security, and actuaries. I've been a part of Great Learning, as I said, from 2021. Great experience teaching data science programs, the business analytics programs, and data engineering programs as well. So what is analytics? We have a cycle of, with so many devices, those and so many ICs out there, especially starting the 90s, we have so much data coming in, right? I work in the insurance business, but not just in the insurance business, in manufacturing, in oil and gas. There's huge amounts of data, right? And that is a result of the digital revolution that we have had over the last 30 years or so. And you have these devices producing a lot of data. And at a lot of times, companies are sitting on large amounts of data and not extracting the value of that and influencing their decisions. So our goal here is to sort of see how data can drive decisions. You might have heard about the term data scientists. We have the term decision scientists as well. So one interesting anecdote: when I joined my first company, Milliman, my first job role was decision scientist. And the difference is very sort of not that different. You do similar types of work, but the approach is a little different. Your role is to influence decisions and not be too specific about the technicality of how you arrive at that decision, right? I mean, data scientists usually work with a lot of languages, build some graphs and charts, and build some predictive models. And the decision scientists, the focus is doing all of that, but also how are those models are going to used in production to drive decisions, or if it's not in use in production, how are some of the analytics that you're doing are driving some decisions. So we'll go and see how data drives decisions in this program. In general, any company has customers, right? And generally, companies like to be customer first. So customers interact with companies through digital methods. So, for example, you may be buying things on Amazon.com. So you're interacting with that business there, right? When you interact with a business, when you go and add something to your cart, right, on Amazon.com, you're interacting with that business, but you're also creating data for them, right? When you type Amazon.com in your browser, or when you open your mobile app and you scroll and then add something to the cart, that is creating data elements for Amazon.com, right? So that goes into a transactional database, right? And by transactional database, I mean there are different types of databases. These are some things that we cover in our data engineering programs. Transactional databases in general cover sort of taken transactions from websites, from places of trade, and these databases are optimized for read and write. So there'll be lots of read and writes. So along with you, maybe 1 million people were on Amazon.com and they added something to the cart, and maybe clicked on a product. All that data is on a very frequent basis getting written to a database, right? So that database is optimized for writing very frequently, right? It's not optimized for analytics or reading or running queries, but writing. So that's the difference between transactional database and something that comes later in the picture is engineered data, right? So from transactional database, you have ETL programs running to take that data, so you added something to the cart along with a number of people, right? You take that data, and then there's a specific type of program called extract transform load or extract load transform, ETL. Amazon.com, especially data engineering teams, would have some of these ETL pipelines or ETL scripts running to take that data in the transactional database and then engineer that data to make it suitable for analysis, right? And so you would see that a lot of times it's not as the one question might be, why can't I perform the analytics on stored data itself? And I think I addressed that question earlier, is transactional data is really not meant for running lots of queries, reading large amounts of data from it, which is what you need for analytics. It's meant for, ingesting a lot of information, and that is what it is optimized for. And so you need certain types of data engineering or data transformation pipelines. So you get engineered data, you have ETL programs that your data engineers write. Engineered data consists of the same data that is there in the transactional database, but maybe a few extra elements, right? Now, when you are engineered data, when you have this data, where do you push it? Right? You push it in a cloud data warehouse or an on-prem data warehouse. Data warehouses are a new concept. Data warehouses are meant for analytics, right? So you might have heard about companies like Snowflake, Redshift is an AWS, cloud data warehouse. These are types of databases where your analytical data would live. So once you have these analytical databases, you push your engineer data there, and then it's ready for your data teams. Now, what are those data teams? A lot of times, data teams work in sync with your product team. So maybe the team that is actually creating that website, right? And there's a data team that is working in sync with it to maybe analyze the data that the product creates, and then in turn analyze that data, drive the whole life cycle of the product again. So let the product manager or the product owner know which features are people interacting with the most, right? So in a lot of sense, for companies, you would see that there's a data team that works along with a product team. What kind of things that this data team does? What are their responsibilities? They do exploratory data analysis, something that we call EDA. They do testing, and then they do modeling, right? So for example, how can I predict, given your customer profile, that you'll add certain things to the cart? What's the propensity of you adding certain things to the cart, right? And then that'll in turn feed in a recommendation engine at the back end. Those are things called predictive modeling. And for predictive modeling, there are wide types of tools that you can use. Machine learning is one tool that you can use. Machine learning, deep learning, recommendation engines. All of these are great tools that you can use to do predictive modeling over engineered data. So your data teams are responsible for that. Your data team is maybe reports to a product manager or a head of product, and then you have generally a data science manager and or a lead or a director, and then you have individual data scientists and data engineers working to kind of create these models. Once you create these models or insights, right? What is the end objective of doing that work, right? When you create a model that says, here's the group of people or the cohort of people that are that have more propensity to add this particular item in the cart. What does that mean? Predictive modeling is one thing. Maybe you just did not do predictive modeling. Maybe you just did exploratory data analysis, which is just data analysis, right? That is historical data analysis. How popular is this particular product, for example, right? So you can put those types of things into a dashboard, something called as BI engines. There are various BI engines out there, Tableau, Power BI. You can take all of that information, put it into a Tableau or a Power BI, and then present it to stakeholders, right? So when you present this information in front of stakeholders, that is when you help them make good decisions. So your analytical methods would in turn drive decisions. Okay. And then what happens after those? So once you drive decisions, that decisions drive some actions. So insights drive some decisions. Once you have some insights, all right, maybe this product is not doing very well. Maybe I should reach out to the seller and see if they can, provide a discount to customers so that, more people add it to the cart, more people buy it, there are more conversions. That is a decision that you would make based on that insight, right? And see how the cycle comes back to customer. Once you make that action on your website, then you would once again see how if the customer behavior is changed, observed, and the whole cycle starts all over again, right? So this slide kind of covers how data and decisions are interconnected, and how in a modern business, data is generated through human behavior, and then that in turn drives sort of analytical insights, which drives actions, and then which once again in turn drive human behavior, right? So what kind of tools and technologies do you think you need for for getting into data science or data engineering or those types of fields. Now, you understand the life cycle of data and decisions, right? That's what I touched upon in the last slide. Once a customer comes on a website, creates some actions that generate some data, and that goes into a transactional database. What do you need to get that data out and put it into a cloud data warehouse, which could be an analytical database, right? How do your ETL pipelines run? So you would see that those are things like Python, SQL, R. Those are good languages to sort of know to learn, and these are pretty popular languages out there. They're used in all sorts of things, not just for software development, but also for a lot of data pipelines, right? And so Python and R specifically are used a lot for data pipelines. SQL in general is used for sort of querying, for once again for data transformations, designing data transformations as well. But Python and R are a little more popular than SQL. SQL is still the bread and butter, though. If you're working with a database, then you need to know SQL. And I think in general, our programs do a good job of kind of just starting from the fundamentals and teaching Python and R and SQL to people who are new to this area. Analytical methods. What do you do with Python and R and SQL, right? So you write code for ETL. If you're doing predictive modeling, you write objective functions. You run machine learning methods. You write code that kind of maybe just cuts and slices and dices the data, right? Groups data together. All of that is possible through these three languages. It is not expected that you know all three, but if I have to choose one, I would choose Python at this time. Python and SQL, in fact. SQL is really the bread and butter, especially if you're working in a product company with a product team. All of that data lives in a SQL data warehouse, and SQL is what you use on your daily basis. Now, what's next? After you have some analytical insights, you need to put it into a BI engine for your stakeholders to review, to sort of take decisions. How do you do that? You do that through data visualization, data interpretation, right? And decision analysis. Data visualization is what we term as, thinking about how best to represent the information that would in turn drive decisions, right? So that could be maybe a bar chart, that could be maybe a pie chart, or maybe just a table, right? So it depends how you present that information. So that field is data visualization. Data interpretation is another thing, maybe just reading that visual and then connecting it to the business, how this particular graph or chart drives the decisions that I'm going to make. And then analysis. So these are kind of what we call analytics essentials, right? So these are some toolkits that you should have to sort of follow all of these processes from data to decisions. And then once again, there are two aspects on an abstract level. You would see that when you're writing code, when you're moving data between systems, these are things called problem solving. You're solving a problem of analyzing that data, generating insights, right? But then when you have the data, when you have the insights, your storytelling skills come into the picture. How you present that information, how you build a story around that to drive decisions. In a lot of cases, when you present data to your business stakeholders, you need to present a story, right? People are really interested in kind of the overall picture of how things will work, or how things have come here, what's the history, and how things will go in the future if I take an action on this insight, right? So you need to present a story. So data scientists in general need to have some aspect of good storytelling also, in addition to sort of having these technical know-hows. Consumers are shifting away from dining out trends towards home delivery services. To tap into this opportunity, the players in the food aggregate industry connect customers, restaurant partners, delivery partners, right? So customers are actually shifting away from dining out, because usually people, use Uber Eats to order food, and customers use these platforms to search and discover restaurants, order food delivery, and read and write customer-generated reviews, right? So entire business model has more, I wouldn't say changed, but more involved in a way that it's a lot more digital now. Every step is creating more data. Many food delivery startups and business are entering the market with great thrust and push, thus making the marketplace competitive and challenging for the firms to sustain, right? So you could see that this is a new area which is garnering more attention from VCs and more investments coming into these areas. And so you would see that there's other competitors that are working together to sort of disrupt the same area of food aggregation. and there are firms trying to solve the same problem. Now, our firm is called 10 Minute. 10 Minute, a multinational restaurant aggregator and food delivery company, has entered the market and as the fastest food and beverage delivery app, providing 10-minute delivery service to its consumers. Okay, 10 Minute is not able to deliver to the consumers as per the benchmark delivery of 10 minutes. Yeah, for sure, they're not able to do justice in 10 minutes. 25% of the orders are taking 50% more time than promised delivery time. So 25%, that's essential, right? 25 plus percent of the orders, right? So among all orders, more than 25% of the orders are taking 50% more time than promised delivery time, right? So close to like 15 minutes or so, 50% more time. This is causing a poor customer experience and tarnishing the value proposition, right? When your entire branding is on a specific delivery time, then of course, even if it's 1 minute late, then you would see that there would be customer complaints. This is so maybe they shouldn't have started, started with the 10-minute name altogether. That is our solution right there. This is causing a poor customer experience and tarnishing the value proposition of the company. On the other hand, 5+% of the orders have been delivered within 5 minutes, right? So there are these 25+% of the orders that are taking more, close to 15 minutes, but then only 5+% orders, right? So maybe around 6%, 7% orders have been delivered within 5 minutes. So there might be some learnings to take away from this. So there are these segments of orders that take less than 5 minutes or 5+ minutes, so 5-6 minutes, less than 10 minutes though. And then there are these 25+%, actually a lot more orders that are taking 15 minutes, right? So what is causing that difference in these delivery times, right? Right. Going back, as a business analyst on this team, you need to identify the factors that impact the time of delivery and what's going wrong with the delayed orders, right? So since the delivery time differs so much in these cohorts of orders, what is it? It's a valid question. What is it that drives the time of delivery and what's going wrong with the delayed orders? Which factor is actually wrong with the delayed orders that's leading to 15 minutes of delivery time? At the same time, also identify what's going good with advanced deliveries. What are some of the factors that are going good with the deliveries that are happening within 5+ minutes, for example? Okay. So as a business analyst, your product owner comes back, your CEO or CDO or whoever is in charge of that product manager maybe, comes back and says, all right, here's what we need to do. We need to understand what is driving the time of delivery. What is our solutions approach? So let's ask a few business questions and frame hypotheses. So once again, like the usual scientific process, we start with some questions and then frame our hypothesis around it. And then we collect data and test those hypotheses, right? So the usual scientific process is that you form hypothesis first, collect data, test the hypothesis. That's what usually data scientists do. That is why they are scientists. What percentage of orders are delivered late to customers, right? So first of all, how large or what is the magnitude of the problem, right? What percentage of orders are delivered late? Is customer satisfaction impacted by delivery time, right? Like, all right, so I see that there are these 15 minutes orders and I say 10-minute is the name of my company, but are people really noticing that difference, right? Are they really complaining? That's a good question. Does weather and traffic density causing delay in the delivery, right? So when I read out all of these questions, right, as a business analyst, you should immediately start thinking about graphs, charts, or tables that you would need to answer these questions, right? So what percentage of orders are delivered late to customers? This is probably a simple number that you can, if you have a CSV or a table where you have delivery times, then you can kind of just set a threshold and derive numbers which are greater than threshold, right? So you should start thinking about the methodology once you read these questions as an analyst. Customer satisfaction impacted by delivery time. Does weather and traffic density cause delay in the delivery, right? So once again, now if we're concerned about customer satisfaction, but now what are those factors that impact delivery, right? So first of all, you'll go back to the data, right? The transactional database, right? Where each delivery happens and then there's a row added. That is the transactional database that you need, right? Go to that database, see what are some of the variables that are available to you, and what are on your also apply your common sense, basic instinct in terms of what could drive the delays in delivery. Is it traffic? Is it weather patterns? Is it some festivals or like a lot of traffic on certain days versus less traffic on others? What is it that's driving that delay? Vehicle of the delivery causing delay. So if your vehicle of delivery is not standardized, are there particular types of vehicle that take long to deliver? Does the vehicle type of the delivery causing delay in the delivery? Okay, so vehicle type. All of these are valid questions. All of these are hypotheses, and you'll collect data to test that hypothesis. We have a Tableau dashboard here for you. Okay, and Tableau is a really good um, BI tool out there. It's a market leader, somewhat being contested by Power BI now, but in general, Tableau has been really a market leader in some sense for business intelligence. All right, so orders by delivery timeout. So we have pre-built some charts and graphs over here that we can see and kind of derive insights. But once again, as a business analyst, these won't be pre-given to you. You need to build this. You need to think about what graphs and charts do I need. So once again, when you're training yourself, I think in general you should also think about what drives decisions, right? Now, if you can write code, you can put data in a tablet database, but your business stakeholder is not interested in running queries there, right? He's interested in looking at this chart and making decisions, right? So in general, you should start thinking about what kind of things would drive decisions. And that is why BI tools are really important, because they help you put your analysis into a language that is easily ingestible by your business stakeholders. Okay, so starting with the first chart here, that's a pie chart. Orders by delivery timeout. I would probably call it a donut chart. 59.99% of the orders are between 5 to 10 minutes. Orders by delivery time. Uh, so you can also see that we have around 11,000 orders, 10,889. Around 25% of the orders are between 10 to 15 minutes. Around 60% of the orders are between 5 to 10 minutes. So the problem is not as bad as we thought, though, right? You're still able to deliver almost 60% of the orders between 5 to 10 minutes. But 25% of the orders are taking 10 to 15 minutes. The green one is less than 5 minutes, and then the black one is 10%, which is greater than 15 minutes. So around actually 35%, 25 plus 10, 35% of the orders are taking more than 10 minutes, right? And that is a problem because your company says 10 minutes. So you have a sense of, you answer the first question of what's the magnitude of the problem now, right? Now, does this cause any significant issues with customer satisfaction, right? So 25% of the orders getting delayed more than 10 minutes. What do you see here? For each of these, you see average ratings, and maybe the customers, rate the orders, right? And then you can, maybe they rate from 1 to 5, and then you can think about, right, 3 plus is satisfied and less than 3 is not satisfied, right? And then you can have this is a process called discretization, where you convert a continuous variable into discrete variables. So after 3 minutes, it's dissatisfied. After 3 minutes, it's satisfied, and below 3 rating is dissatisfied, right? So you have satisfied and dissatisfied. Now you segment that data for each particular cohort of delivery times, and then you see for greater than 15 minutes, 90% people are dissatisfied. For 10 to 15 minutes, 35%. So definitely, people are getting sort of frustrated with long delivery times and giving bad ratings, right? You can see that 35% for 10 to 15 minutes are bad ratings, and for greater than 15 minutes, those are 90%. Okay, so you've answered your second question now, right? Now look at this one, effect of weather. right? So you can kind of just see effect on weather here. Uh, this is uh, this is a great chart that shows you how much what has been the weather patterns over every time that the delivery has happened, right? And this is when you have a column which has your delivery times, but then under the column in your data which has weather patterns, and weather patterns can be stormy, windy, sandstorms, cloudy, sunny, fog, right? So you can see that what are some of the biggest squares or boxes over there. Some of the biggest squares are stormy, greater than 15 minutes. So you see, this category is pretty huge. It takes longer than 15 minutes and it's stormy. So a lot of the greater than 15 minutes have stormy weather, right? A lot of greater than 15 minutes also have fog. A lot of less than 5 minutes actually are windy. So we have answered the question. So weather definitely affects the delivery times. Stormy and fog lead to long delivery times, right? Are there any patterns in deliver of weather when delivery time is very less, right? So you can see that what is the pattern between less than 5. Stormy, windy, it's fog, it's not very clear. So all of those are very small effects here, very small boxes, right? So this type of chart is useful to tell you what are some of the biggest drivers of a particular categorical variable like weather. Now, let's change this to road traffic density. And then let's also analyze how much road traffic density could drive the delivery times. So when road traffic density is high, you would say that it takes longer than 15 minutes. High, it takes 10 to 15 minutes. Low, takes 10 to 5 minutes. So road traffic, I mean, what is the insight that we got from the earlier chart? The insight that we got was weather uh, does affect long deliveries that take longer, right? So for example, weather could affect delivery times in general. It does not affect delivery times when weather is fine, but in general, if the weather is bad, then it definitely affects the delivery time, right? With road traffic density, the effect is both ways. If road traffic density is high, then it leads to long delivery times. If it is low, then it leads to shorter delivery times, right? And so you would see that these are great effects. Our hypothesis is we had made the correct hypothesis at the start is that weather and traffic patterns do affect delivery times, right? All right. So in general, that is our analysis here. Effect of vehicle condition. Those are two additional questions that we had. What is the effect of vehicle condition? Uh, in general, you would see that green is good, blue is okay, and then gray is poor. So in general, less than 5 minutes, 60% of the vehicles are good, but greater than 15 minutes, you see. So I'm just looking at the extremes right now. Greater than 15 minutes, you see that around 51% of the vehicles are in poor condition. So apart from weather and traffic patterns, your vehicle condition also affects the delivery times, right? All right. Effect of vehicle type. It's an electric scooter or a motorcycle. You see that if it's a motorcycle, it 75% of the orders which take longer than 15 minutes are usually done through motorcycles. Orders that are done between 5 and 10 minutes are done between 72%, right? So this is kind of counterintuitive in a sense, at least motorcycles. I would expect that greater than 15 minutes do take actually longer. Actually, you'll see that the other option is electric scooter. It's not a car. So electric scooters are actually, maybe more maneuverable in a good traffic sense. And so usually whenever there's an electric scooter, you would see that those deliveries are delivered faster. That is what we see here. All right. So you see that all of these are, I mean, I'm making causations in general that, all right, so delivery time, vehicle condition, weather drives delivery times. But in general, you absolutely cannot make causative causation relationships with graphs like these. There may be a third factor which is affecting maybe both delivery time and the vehicle. Maybe something is the way these orders are allocated to people are also a factor, right? Uh, But in general, these are from this short analysis that we did. It seems like, going back to our slides here, it seems to us that around 35% of the orders are delivered late. Customer satisfaction is impacted by delivery time. Weather and traffic density do cause delay in the delivery and does impact delivery times. Type of vehicle and the vehicle condition also affects delivery times, right? So you can see, without building predictive models, with just basic graphs and charts, we have been able to give some insights, right? So just to summarize, around 65% of the orders are delivered on time. As the delivery time goes up, customer satisfaction also goes down. Late delivery greater than 10 minutes are caused by bad weather and heavy traffic. Orders having delivery time greater than 15 minutes have 76% of the vehicle that are motorcycles. So motorcycles do take longer. Electric scooters do take shorter. Orders having delivery time late delivery have 50% of the vehicles that are in poor condition. So condition of the vehicle also affects delivery times.